Welcome all. In last lecture we have seen a clocked SR flip-flop. Today we will see a clocked D flip-flop. Clocked D flip-flop is an age-triggered D flip-flop. It can be of two types: a positive age-triggered D flip-flop and a negative age-triggered D flip-flop. We will see in detail these two types. Before that, we will see the application of D flip-flop. It can be used as a delay element and it can be used in the digital latches. So first we will see a positive age triggered D flip-flop. This is the circuit diagram of positive age triggered D flip-flop. Basically, this flip-flop is invented to overcome the drawbacks of SR flip-flop, which are when S and R both are zeros, then output will not change or output goes into the invalid state. Also, when S and R both are 1 1, then also output will not change or it can goes into the invalid state depending on the type of gate used to construct the SR flip-flop. So following figure shows positive age triggered D flip-flop. The circuit shown below will operate as an D flip-flop only for positive clock age, but there is no change in the output for the negative level, for the positive level, or for the negative going age of the clock pulse. The D flip-flop is gated SR flip-flop with NAND inverter connected between its S and R input. Basically, this portion is of SR flip-flop. The S and R terminals are connected together through this NAND gate, and this NAND gate is going to act as a NOT gate, as both the input terminals of this NAND gate connected together to a common input that is named as a D input. The flip-flop has only one input denoted by a D. Due to the NAND inverter between S and R terminal, S and R will always be complement of each other. Hence, S equal to R equal to 0 and S equal to R equal to 1 input conditions will never appear, which will overcome the drawback of the SR flip-flop. Means SR equal to 0 0 or SR equal to 1 1 conditions will never occur, by which the drawback gets overcome. This is the symbol of the D flip-flop. This is a D input, these are the two outputs Q and Q complement, and this is a clock input. And for this clock, a symbol is shown like this, which shows that the flip-flop is an age triggered flip-flop. Now we will see the operation of this flip-flop. We will consider the case 1 in which the D input may be anything, it may be 0 or it may be 1. Therefore, it is shown as a don't care condition. It can take any values. But the clock input for this case is considered as a low level of the clock or high level of the clock or negative age of the clock pulse. As this flip-flop is sensitive to only positive age of the clock, it will not respond to the positive level, negative level or negative going age of the clock pulse. So when clock is a negative level or negative edge, then the input to this NAND gate 3 and 4 will be 0. Through this terminal we are going to connect a clock input, that is enable terminal. As gate number 3 and 4 is having at least one input 0, their output will be 1, means gate number 3 will have a output 1 and gate number 4 will also have a output 1, by which R dash and S dash inputs goes high, which are the inputs of this SR latch. Already we know the truth table of SR latch using NAND gate, which is shown over here. Now R dash and S dash both are 1. This is the condition when R dash and S dash both are 1. At that time output will not get changed, hence output of basic D flip flop, here by mistake SR flip flop is written, output of basic D flip flop, that is Q and Q complement, will not change irrespective of the D input. Now we will consider the second case in which the D input is 0 and clock is considered as a positive edge, means the flip flop is now going to get enabled by the positive edge of the clock pulse. Now since D is 0, the S input will become 0 and R input will become 1 through this NAND gate. So since S is 0, the output of NAND gate 3 will be 1, by which R dash will become 1. Now the input to this NAND gate 4 are, the R input is 1 and clock input is 1. So 1 1 will gives you the output of NAND gate 4 as a 0, by which S dash will become 0. Now these R dash and S dash are the input of the basic SR latch. So when R dash is 1 and S dash is 0, this is the condition. At that time output is going to get resetted, means Q will become 0 and Q complement will become 1. So with D equal to 0, the next state output, that is Qn plus 1 will become 0 and Qn plus 1 complement will become 1, which is the reset condition of the flip flop. Now we will consider the next case in which D input is 1, clock is considered as a positive edge of the clock. Since D is 1, the S input will become 1 and R input will become 0. Now gate 4 is having at least one input 0, so its output will be 1, by which S dash will become as a 1. Now gate 3 is having two inputs, S which is 1 and clock input which is also 1, by which its output will be 0. Therefore R dash will also be a 0. So which R dash and S dash are the input of SR latch again. So for R dash 0 and S dash 1, this is the condition of SR latch truth table, by which output gets set, means Q will become 1 and Q complement will become 0. So with D equal to 1, which are the input of SR D flip flop, Qn plus 1 will be 1 and Qn plus complement will be 0, which is the set condition of this flip flop. Now we will see the truth table in which all the cases get summarized. In this, inputs are clock and D input and outputs are next state outputs, that is Qn plus 1 and Qn plus 1 complement. So as the D flip flop is a positive edge triggered, it will not respond to negative level, positive level and negative edge of the flip flop. Irrespective of the D input, output will not get changed. So for the positive edge, when D input is 0, output gets resetted, that is Q will be 0 and Q complement will be 1. When clock is positive, D input is 1, output will get set, that is Q will become 1 and Q complement will become 0. So from this truth table it is clear that the Q output of flip-flop follows D input, means if D input is 0 then Q also be a 0. When D input is 1 then Q will be a 1. Now next we will see the negative edge triggered D flip-flop, which is shown over here. This flip-flop will respond to only negative edge of the clock pulse. It will not respond to the negative level, positive level or positive going edge of the clock pulse. Remaining operation is same as I have explained earlier. This is the symbol of D flip-flop. This is the D input, these are the two outputs. A clock input is connected. This shows that a negative edge of the clock is applied to the flip-flop. This is the truth table. Again, as the flip-flop is a negative edge triggered flip-flop, it will not respond to negative level, positive level and positive edge, by which output will not get changed, and it will respond to negative edge of the flip-flop. When D input is 0, output gets resetted, and when D input is 1, output gets set. Again, from this truth table also we can say that the flip-flop follows the D input, means when D is 0, Q will be 0, when D is 1, Q will also be a 1. Now we will see one problem based on SR flip-flop and D flip-flop. We have to study this given diagram and we have to find the D input to make this LED on and to make this LED off. First we will see how this LED can be gets turned on, and for that what should be the D input. Now to get turned on this LED, the output of AND gate should be high. So to make output of AND gate as a high, if we see the AND gate is having one input connected to plus 5 volt. So to have a high output of that AND gate, we should have a output of SR flip-flop, that is QA as a high. So to get QA high, that is we have to set this SR flip-flop, for which the set input of SR flip-flop should be high and reset input of SR flip-flop should be low. That is S equal to 1 and R equal to 0. Hence output of D flip-flop should be high, that is this Q should be 1. If Q becomes 1, it will make automatically S as a 1 and R as a 0. So to have Q, that is output of D flip-flop, to be high, we have to make data input of this D flip-flop as a 1, which will gives the Q output 1, which will make set input 1, reset input 0, by which we will get the output as a 1. As we know, if set input is 1 and reset input is 0, output of SR flip-flop gets set, that is Q becomes 1, and this 5 volt will gives output of AND gate as a high, by which this LED gets turned on. This is regarding how to turn on the LED by deciding the D input. Now we will see how to turn off this LED. Means for that what should be the value of D. Now to turn off this LED, the output of AND gate should be 0. To make output of AND gate as a 0, we have to get QA as a 0, by which output of AND gate will be 0. So as QA is 0, its output is in reset condition. For that we need S input of SR flip flop as a 0 and R input of SR flip flop as a 1. So for that the Q output of D flip flop should be 0, by which this S will become 0 and R will become 1. So to get Q output of D flip flop as a 0, we need to connect data input to the 0. So if data input is 0, we will get Q output as a 0, which will make S input as a 0 and R input as a 1, by which this SR flip flop gets resetted to make QA output as a 0. So this QA output is given as an input to this AND gate, which will make output of AND gate as a 0, by which the LED gets turned off. So to turn on, data input should be 1, and to turn off, data input should be 0. This is how we can predict the value of data input to turn on and off the LED in a given diagram. Thank you.